Hello, everyone, and a very warm welcome to KognitoKey. I'm so thrilled you're here. If you've ever wondered how those massive, complicated databases just seamlessly work behind the scenes, well, you're in exactly the right place. Today, we're demystifying database management systems, focusing on the view of data and its incredible architecture. So, let's jump right in.
Think about it. Almost every single time you open an app, you're interacting with the database. But behind the scenes, those databases are overwhelmingly complex. We're talking intense hardware, complicated storage structures, the works. So the big question is, how do developers actually hide all that messy complexity from everyday users? Well, that's exactly what we're decoding today.
Here's our roadmap for today's explainer. First up, data abstraction. Second, the three-schema architecture. Third, data independence. Fourth, instances versus schemas. And finally, our key takeaways.
Section 1. What exactly is data abstraction? Abstraction is truly the hero of our story here. It's basically hiding complex data structures to simplify how a user interfaces with the database system. Because the reality is, most people using a database aren't computer engineers, right? They really don't need to know exactly how data is physically laid out on a hard drive. So abstraction keeps all those highly technical, gritty hardware details completely hidden away, making sure your interaction with the system is smooth, intuitive, and totally seamless.
Moving on to Section 2, the three-schema architecture.
To pull this off, we use a three-layered approach. Let's build this layered cake from the bottom up. Step 1 is the physical level, sometimes called the internal level. This is where data actually lives on the hardware, dealing with all those complex structures. This is strictly the domain of the database administrator. Moving one step up, we hit Step 2, the logical level. This layer describes what data is actually stored. Think entity sets and relationships. If you're a programmer writing SQL, this is where you live. And finally, Step 3, the view level. This is the highest level of abstraction. It only shows a very specific part of the database through a user application. This level, that's built for you, the end user.
Okay, let's ground this theory with a real-world example, like a college database. Imagine we have a student entity, a lecturer entity, a department entity, and a course entity. What's super fascinating is how these entities look completely different depending on the layer. At the logical level, programmers are actively defining these entities and linking them up using a language like SQL. But down at that hidden physical level, those exact same entities are just being stored as raw consecutive blocks of memory on a hard drive. The absolute beauty of this architecture is that a student checking their class schedule at the view level doesn't need to know a single thing about those memory blocks.
All right, Section 3, Understanding Data Independence.
So data independence is the magic rule that ensures an update to one layer doesn't bring the entire system crashing down. We've got two types to look at here. First up is logical data independence. This is your ability to change the logical schema, like say adding a brand new clubs entity to our college database, without altering the external user views at all. Second is physical data independence. This means your database admin can literally go buy new hard drives or reorganize files at the lowest hardware level to speed things up, completely without touching the logical design or the user applications. Basically, you can tinker with the lower levels without breaking the higher ones. Next up, Section 4, instances versus schemas.
There's a really important duality here in computer science. An instance is the actual information stored in the database at one specific moment in time. It is constantly changing as data gets inserted, updated, or deleted. On the flip side, the schema is the overall definition and structural design of the entire database, and that rarely ever changes. To go back to our college analogy for a second, the schema is basically the architectural blueprint of the college buildings. The instance, well, that's the ever-changing roster of students enrolling, walking through the halls, and graduating every single day.
And finally, Section 5, our key database takeaways.
So let's wrap this up with the crucial points you need to remember. First, abstraction is what simplifies the user experience by hiding all those complex data structures. Second, the three-schema architecture is what effectively separates the physical hardware storage from the user applications. Third, data independence acts like a protective shield, keeping higher levels safe from modifications made at the lower levels. And lastly, schemas are your static, unchanging designs, while instances are dynamic, real-time snapshots. Understanding this dynamic beautifully bridges the gap between everyday users, software developers, and database admins.
Thank you so much for joining me today. If you found this explainer helpful, please subscribe to KognitoKey. Go ahead and like and share this explainer to unlock even more tech insights. As you go about your day, just ask yourself, how much invisible, highly structured data architecture are you interacting with every single time you open an app? It's pretty wild to think about. Until next time, keep learning, keep growing, and I'll catch you in the next one.